Alright, so let's look at machine learning part 2. Today, I think this is actually part 5, and we want to look at what? We are going to look at unsupervised learning. So let me share my screen and get straight to, of course, right, so my entire screen is being shared now, and so we want to look at supervised learning. And if you've been following my video tutorials, you know that under unsupervised learning we are actually looking at a data set which are all independent, or which has variables which are all independent. So all the variables are independent variables. You do not have a dependent variable in it. And so I'm just pulling up my R Studio. And so we had already looked at supervised learning, and then if you can check, so that's what I'm just scrolling through. And so let me close this side. Okay, maybe that may not be necessary for now, but so before we can I'll just show you what is supposed to be done. You know, there's an inbuilt data set called iris. What is it? Iris like this. So if I should just have, let's say, a head, just look at the iris data. Of course, I'm just going to run that. Okay, I've not spelled the head properly, so let me run that line again, and let me fold this up. You're going to see that these are the iris data. So we have sepal length, we have sepal width, and then what is petal length, and then petal width of these species of, let's say, a particular flower. Okay, so we are going to use, and you notice that the data set is actually not having any kind of pattern. I'm saying there's no pattern because there's actually no dependent variable in it. So all the variables are independent. So none of them depend on the other. So we are going to use unsupervised learning. But you should remember that because this data set, or the data point we are seeing here, are continuous, what is the data point, so we can say that all the variables are having continuous data points in it. So we are going to use what we call clustering. So if they were categorical in all of them, or if some of them were categorical, we would have used something like a different approach, maybe a particular different model. So what do? First of all, you must know that in clustering, you need to put the data in the form of a matrix. So the data will have to be in the form of matrix before you can do that. So first of all, we have the data which is around here. So, but we need to make sure that we change it into a matrix form. But remember that when we did the head of the data, we had this last column, and that particular last column means that they are non-numerical. So they are characters, and we don't need that when we are doing our matrix. So first of all, we need to isolate that particular column out. So it's actually from column 1 to 5. So we are just taking this particular line, and we are saying that we are just picking from column 1 to 4, leaving column 5, and we pack that to this new data set. So I'm going to run that, and you see that the new data set will not have it will not. So if I do the head of the new data set, you will notice that that particular part, the last one which was on top here, the Situsa, is no longer there. So now we can now form a matrix using this function called the as matrix of the new data, and then we pack it into this. And now our matrix is now ready. And remember, in unsupervised learning, if you are looking at clustering, one of the means of doing clustering is k-means. So we use the k-means function, and we are clustering the data into about 4 different clusters. And so I'm packing everything to here, iris clusters, and that's why I'm using the function k-means. And then I am clustering this particular matrix that we just generated right now. And then what clusters do we want? We want 3 clusters, and so it's going to give us cluster 1, cluster 2, cluster 3, and then we pack everything into this variable called iris clusters. So we run that, and that is already there. If we decide to have a look at just, but after we've done that, the next thing to do is to make sure that we combine the iris, the original data, which is iris, together with the one we have just clustered right now. Immediately you do clustering, a column is created, and that column is called a cluster. It's automatically created. It is called a cluster. For instance, if you come here, if I enter here and I decide to say head, if I should do a head of the iris class, just a minute, the iris underscore class, which is there. So if we should run that, you're going to see that there's a new column that has been created. Okay, but at the moment it is because at the moment it is still what do we call it, a matrix. That is why I am unable to let you have a view of it, the iris class. So maybe when we combine it, you will see. So we use the cbind function to combine it with the original iris data together with the new column that has been created automatically due to this particular this thing, and then we pack everything into this particular thing called this variable called the final class string. And now when we do that and then we run that particular line, so it means that almost, so if we go to have a look at the final class string, let's see. So you can see that the final class string is out here, and what do we see? We can see that it has now classified all the data set into what is it? So we can see the cluster here. So that's the cluster, the new column that has been created. And so when we combine it, this was the original data, and we combine the cluster into it, and then that's all that we have done. And so we now have our cluster of like 3, 3, 1, 1, and whatsoever. So I can actually just pick out one cluster. And how do I do that? I can just come here, and then maybe I now want to know one cluster. And this clustering is based on the distances, how close some of the features like the petal length and whatsoever, how close they are. Then you classify the flower, the flower based on their petal length, their sepal length, their sepal whatsoever. So that's what is just going to happen here. So how do I take out only one? Let's say, how do I take out just one cluster? Maybe let's try this function here. So here is that's my data frame here. I don't know if this is going to work, but I can just try that and see the final clusters here, and then I'm piping it, and I'm saying that I want the column, this particular column, and the column iris class, and then the other class. So that's going to be iris. Okay, that's the variable. And then we are saying that if it is equal to, in this case, we are not looking at if it is equal to 3 or is the same, that in that particular column is going to take only those that are like just 3, and then we pack that to new variable and call it, that's the let's say cluster 3, cluster 3, like this. Run that line, and okay, they say we couldn't find this particular function called this pipe operator. What that means is that we need to activate dplyr, and then when we do that, that particular package will become active. So I'm just coming here to make sure that I take out dplyr. So I have the dplyr package. That's the package that allows that function to work. And so I can come again and now come and run it, and then that works just properly. So now if I come and I want to print out cluster 3, it's going to print only the 3, 3, 3, 3. And can you see that? So it now grouped the data. I can take only the 3, 3, 3, 3. So if I can do that for the rest, and then I'll be able to now know that my data has been clustered, and then whatsoever. So I can, that's the clustering, and then that's how we are able to use machine learning to be able to do this kind of clustering or this kind of analysis. This is called unsupervised learning. But there are instances that you may also want to use the other part of clustering, which we call the principal component analysis. And so we can use a function called the printcop, and that one too, it takes a matrix data. So we've already generated our matrix data, if you can remember, which is here. So we just come here, the printcop, and then we pack everything here and call it cluster 1. And so our principal component analysis, it has also done its own clustering. And of course, we can decide to have a view. We can just look at how this clustering is done using this function called the fvis eigenvalues. And so when I run that, you can only do this. you only be able to do this if you have this particular function, and then you have to install the package called factor extra. What is it? When you do that, you activate this particular package, and this function will be working. So now we are looking at the principal component analysis of the three of the three flower species that we have, and then you can see that the script plot is here. So in very normal sense, we always deal with the cluster 1 and then the cluster 2 here, especially where the arrow where you have an elbow. So you can see the elbow at this particular point. So that's why we are supposed to. So we are going to consider this component and then this particular component, and then so we extract those ones, and then if you want to do further analysis, we do that. So that's also the principal component part of it. We could have also looked at it using the different what's the category. So you can see that. So you can see this, the sepal length or whatsoever. So we also have different ways of visualizing that. And of course, we could have also try to look at the network, and then that's for principal component analysis. And as you can see, we have our sepal width, our sepal length, and then that's how this part of analysis, unsupervised learning, allows us to be able to do. So this is just one of it. The iris is an inbuilt data. So I decided to simulate my own data, and then let's check it. And then I was just thinking that maybe if we have students, and then we are looking at the student, their weight, their height, the stipend they are being paid, their feet length, and their arm length. If we want to measure whether there is some, so if you look at the whole data, if I run the whole of this, what I just have done, I can just do that, and you'll notice that everything runs properly. So we have our our data frame that has been created. So you can actually have a glimpse of it, and this is how it looks like. So let me just bring it down a little bit so that we all can see. So we have the student, the arm length, the foot length, the student height, weight, the stipend. You see that all of them are independent variables. So if you want to do any kind of analysis here, the best is to simply just do some kind of clustering. So we want to classify this, what it is to be one of these students. It's the same approach that we are going to use. So what are we going to do? First of all, we have to change that data into matrix. So I run that particular line, and we use the k-means to be able to visualize, or to be able to put that into 3 clusters. Then the clusters are here. So, but if we want to be able to see the actual clustering, so I'm going to jump this line for now, but I can see run it doesn't have any problem. So if I come here, then I use my cbind, combine the original data plus that new column that has been created, which are just 3 clusters. And when I do that, yeah, it will be here. So now when I print the final clustering, it's going to cluster the students into like 3 groups. So you can see that I now have 1, 2, 3 group. And so now, just like the same way I did, I can just siphon out I can just come here, and then I'm just going to take the student because the final cluster is now what we are looking at. And so when I go there, I just want to pipe out a particular, so I'm going to pipe out one of the classes, and we'll look at the students who fall under that. And so what I'm going to do, I will just say I have this, so I'm piping out. So I'm going to use percentage greater than percentage, and then when I pipe out, I'm going to filter, and then when I filter, then I get into this particular data set, and I'm saying that I'm filtering based on the clustering. Remember, I am filtering based on the clustering. So if I come here, all that I want is this column. So I'm going to come to this column, and I'll say that I am filtering based on this column, and then I'm just going to copy that because that's where the clustering is actually done. And so I come here, I'll just paste it there like this. But in this case, I'm saying that if anything is equal to cluster 1, and so that's all. And then if I run that, but in that case, let me pack it and put it into a variable, and then that variable will be called, let's say, what is cluster 1. And then if I run that, it will pack that data into cluster 1. So now if I should run cluster 1, you will see that, okay, let me fold this up. You see that it will select only all the students who are in cluster 1. The data has grouped them in cluster 1, and this particular grouping is based on some level of similarity. Using whatever algorithm that at all that has been put there. So that is it. We could have also gone ahead to do some further studies. We could have plots. We could do some kind of plotting here, and then we just have a look, and then yeah, so we can have a look, but this doesn't make sense. We could do the same this one, and so we are plotting to look at principal component part, and that's why we run this particular line here. And then to run the principal component, you run it based using the matrix data that you created from the data frame of the students, which is student M here, and pack everything into student PCA. That's the principal component analysis. And then when I come here, I can now visualize my principal component analysis using this function, and then I'm saying the double is equal to true. When I do that, yeah, it gives me this particular script plot telling me that, well, I can use the first and second. So the first, we have this a similarity index, and then the second, as we continue, the similarity index of 1.7 is just, that's too low, but obviously we're going to use this particular component. So this is how we are able to do unsupervised learning and be able to build our model. And this where I'm using classroom. Maybe I could have done something like I'm here with correlation of correlation of all the so the correlation coefficient have been created. If I can print and you see that look like, you can see all of them, their coefficient have been created. So, and then we can just generate a heat map of the correlation coefficient, and you see how that looks like. And if I print this, so this is the relation of the student's height. That the student height have any kind of correlation with the student, let's say, any of this, the bottom here and then over there, doesn't happen. You can see that the correlation is practically 0. It's very minimal. But when you have this kind of graph like this, heat map like this, you may be deceived when you are interpreting the data. That's why I needed to print the correlation coefficient for you to see. Sometimes the correlation may not be strong, but it is there. Here, like for instance, I can see I have like 0.04, okay, like here 0.09. So there's some level of correlation, but a very weak one. There's also negative correlation, weak negative correlation at some places, and then but in general we can interpret it and say that there's actually no correlation at all. So it means the student weight and then the student height do not have any kind of correlation. It doesn't mean that those students who are heavy are also tall. That's what that means. Or it doesn't mean those who have their feet length longer, they are also taller. No, we haven't seen that. But because it's a simulated data, perhaps if it was a real-time data, we could actually see the pattern. But this is just how we are able to do some unsupervised learning under machine learning. This is just one part. I'll be doing association in details, and then I'll be doing what the Markov model also in details. Each of them we would try and then break it down. I'll be going forth and back. I will still do unsupervised learning. What is it? And then where we can look at the trees and how to generate them, how to interpret them. We will look at the random forest, and then we'll look at all the models which are all the time used in machine learning. But this is another part of machine learning, and I hope you get to understand. Now, let me just summarize what I have done here. In machine learning, when you get your data and all the variables are independent, you know that you are going to employ machine learning approach, you should look for unsupervised learning. That's it. And then under unsupervised learning, check the data, whether the variables, the data points are continuous or categorical. If the data points are continuous, then you should be thinking of doing clustering or association analysis under unsupervised learning. And to be able to do that, either clustering or association analysis, you should make sure the data is in the matrix form. So if the data was in, let's say, a vector form, it was a time series data, it was a data frame, you have to transform the data into a matrix data first. And when you do that, and to transform the data into a matrix data, you have to make sure you don't have the character column over there. So sometimes you take the character column out, leave only the numerals, then you form your matrix data. And after that, what is the next thing? Now your matrix data is ready. The next thing is to now do your clustering. And what kind of clustering are you going to do? If you are going to use k-means, then you now use your k-means function. Then you do your clustering based on what you want. You can do your clustering up to 4 or 5, depending on the way you want it. Then the machine will simply do the iteration and cluster it for you. Now, if you want to have a feel of it, then you now combine the cluster column to the original data. Then that will now allow you to see which ones have been clustered under cluster 1, cluster 2, cluster 3. And then after that, if you want to visualize it, you can actually use your principal component analysis, which also runs with a matrix data. So your matrix data is already there. Then you run your printcop with it. Then that's going to also give you a new variable. And then that particular new variable can then be visualized using FV's underscore the eigen value to be able to generate the script plot. And the script plot allows you to know upon all the components that you have generated, which of the components can you use for further analysis. And it's usually the component 1 and then 2. In some cases you may add 3, but it's always component 1 and then 2. Especially where there is an elbow, that's where you end. And then this is just how it is. Then you go ahead and then do your interpretation. Perhaps if you want to do an association analysis, you could do you could generate a heat map. You could also generate a correlation, and then you have your correlation coefficient, which you can visualize it the way you want, and then you can interpret it and then go ahead. So this is how unsupervised learning part 1, unsupervised learning, the first one, but this is actually my part 5 of the videos. If you enjoyed the video, why don't you give me a thumbs up and please share for other people to follow. Thank you, and then I'll see you for the bye.